Okay, let us go ahead and get ourselves started with session 7 of 120B, 220B. Today we will continue talking about a lot of building envelope considerations. We're going to talk about lighting, daylighting, as well as artificial lighting and energy, and how some of these factors impact the way we think about designing facades. So we're going to spend a lot of time thinking about our building envelope and really some of the features of the envelope and how we can do some analysis to make sure that we're achieving our goals and getting the performance we want inside the building. Towards the end, I want to just start pointing the way to thinking about structure. One of the things we're going to think about that's related to the building facade is to start thinking about really where is the facade relative to the structure. Because like a lot of different systems, you can approach it in multiple different ways. You can have sort of things where they have an internal skeleton and the facade wraps around it all, okay, which is a very conventional way of doing it. But the facade can be actually right in line with the structure or even inside the structure. And I'll show examples of buildings that sort of, do it all the different ways. So it sort of is related to building envelopes because you want to start thinking about where the weather separation boundary occurs relative to the structure. And it's not always where you suspect it to be. Okay, as we get going, just some things to comment on for the integrated design project. Go ahead and this week where we should be posting things, it's just all about kind of our sort of building envelope, our passive design features, just kind of as most of you are moving from sort of these general concepts about what you'd like to accomplish with a building to a more defined building form in terms of where the spaces might be, how the spaces are organized, and where the individual buildings and their boundaries might be. It's just to talk about those things and then start thinking about really for those different spaces you're defining, is there anything about either passive design features or the envelope you can start describing now? There are some faces where you want to have big glass facades that sort of either bring in natural daylight or bring in heat because you want to use that. Other places where, because of your programming, you want to shield yourself from the direct view or direct sunlight coming in through the walls, but you might try to bring in daylighting through the roof or some other, an atrium or some other way of bringing daylighting into the space. So it's just to kind of think at a high level about what your strategy is, with the idea that then we'll go ahead and articulate it and build it out in your actual designs. But just kind of keep moving around. As we met with everyone, people are in pretty good shape about the initial design concept. But this is really sort of a critical week. If nothing else, somehow all those clouds and bubbles start translating into things that look like real walls in Revit. Okay. Again, they can still move around a little bit, but they have to firm up just a little bit more. There are some check-in times posted out there in Canvas, so if you can, find yourself a time to sign up for meeting with us. We have got one slot this afternoon, pretty much all day tomorrow, sometimes on Thursday, a couple on Friday morning. Those are times when I'm definitely available. I'll have Alana and Angad sort of add their own times into that, so if the matrix is fuller and there's even more times, they can meet together. We don't have to do them all together, but we'll sort of sort out coverage so that we kind of spread it and kind of keep it diverse with everyone meeting with new people for new and interesting ideas. Because I just have a subset of ideas. Okay, relative to other things to work on, these little exercises turn out to be a pretty good way of just sort of flexing your muscles and just trying to apply things in a way that's a little less open-ended than your own design project. So there's an exercise 2 which is posted out there now. Again, the goal is to really go ahead and spend an hour on it, something like that. What exercise 2 looks like is, actually I'll go ahead and open the building first. Let me go out there and I'll open the building. Let's see if I can find it out here. There. Exercise 2. Okay, this building is brought to you courtesy of your good friend Angad, who has provided you with a nice little 2-story L-shaped structure. It's kind of very plain right now. It's a little brick wall, something like that. Doesn't look like there's any roof overhangs on it. It's just kind of a blank slate, a blank canvas for you to work with. So as you think about this, the idea is to just go ahead and start thinking about some sort of strategy for, let's go and read it what his assignment says. Where did canvas go? Sign in again. What did I do? Okay, popping in here. Assignment 2, or exercise 2, right down there. Building envelope strategies. So for next Tuesday, go ahead and think about these things. So on this basic building that Angad has put together, this blank canvas, provide an envelope strategy. Sort of come up with some sort of thinking about how you're going to use that envelope with an attempt to minimize building energy use, which is one very strong goal that guides a lot of us to think about really, where we can go ahead and either prevent heat from leaking out or capture energy that we might be able to use to heat the building. Okay? And maximize daylighting, which is again sort of a very nice consideration. It often guides us in terms of where we put windows, trying to get daylighting into the core of the building so we don't have to use so much artificial lighting. Okay? And go ahead and illustrate that design kind of through the wall construction, so these sort of surfaces, the structure of the walls, the thermal properties you might put in there, windows and curtain walls, just sort of illustrate where those might be. Think about shading features. So either roof overhangs, or we'll talk about shades on individual windows, how you might incorporate some of those. So use any material or type of construction, and just really think about the building envelope, so there's really no need to kind of think about modeling all the interior of the space. But it's really just, given that big blank canvas, just starting to think about how you would use it. And that might be dependent on where you're choosing to put the building in the world, what the south versus the north versus the east versus the west is. But just start thinking about it relative to that building. In terms of, you can imagine your own sort of program you might have in there, but you can think about, do I want to put a lot of windows on the southern facade? This is sort of facing southeast or southwest right now. Sort of what sort of articulation I might want to have here versus that northern facade. So south will get a lot of sun through the day. West will get a lot of sun kind of late in the afternoon. North will get a lot of no sun directly. It'll always get daylight. That's kind of an interesting thing about daylight. We'll talk about that as we're talking about it. It's omnidirectional on the eastern side. If you want to orient the building or reorient the building, that's fine too. Okay, so yeah, whatever you would prefer to do. But just go ahead and play around with it. Okay? Right now you'll see it's all just a single type of construction, which is, what is it? It's the brick on, let's see what it is. A lot of flashing. Brick on metal studs that has some sort of thermal properties associated with it. Okay, actually very good thermal properties. There must be a lot of insulation in that wall construction. You can change that, start thinking about things you might want to have there instead. But again, don't belabor this. Spend most of your time on your project, but go ahead and do something here just to kind of start playing around with, well, we'll show you how to do daylighting analysis and stuff like that. That might be a good building to kind of illustrate after you put some windows and some facade features in here, just on this building, how you could actually get daylighting back into this core. Because in that core of the building, kind of back over in there, that might be hard to get daylighting in there. So we can think about side lighting versus top lighting. If you want to put like a skylight or some sort of atrium in there or something like that. Okay. So that'll get us going in terms of thinking about that. Any questions?
Is there a location specified for this?
There is not. How about go ahead and make one? Yeah, choose whatever you want. So, and always have more fun. Like if you really want to sort of warp your brain, go ahead and put it in the southern hemisphere. If you put it in Sydney or Melbourne or Rio or something like that, all the rules, it causes you to think twice because it's backwards the way you think about the sun, or backwards the way we think about the sun. So now, go ahead and choose something. Again, you could also, it's sort of more interesting if you choose a very hot weather climate or a very cool climate. Okay, so if you think about putting it somewhere in the Middle East or putting it somewhere in the middle of Asia or even somewhere in the middle of Africa. We don't do enough architecture in Africa. It's like we got to put more examples there. So just think about someplace. It makes it a more interesting exercise. Palo Alto is so boring. Everything's easy in Palo Alto. It's the middle of January. At the end of January, and what is it? You could be sunning out there. It's pretty nice out today, right?
I wore like 4 jackets. I don't know
Well,
why.
that's because you're from Southern California. It's like, come from Kansas or someplace where it's not.
Actually, so.
It's different. Okay. In terms of our building envelope and thinking about it, just a couple issues before we dive into analysis and modeling and Revit and stuff like that. So much of it really comes from, we have all these different design goals. We talked about them last time in terms of must-haves and nice-to-haves. So much of it really, though, comes down to what I'll call striking the right balance, the optimal balance. It is really quite hard because as much as I can put a lot of glass and sort of glazing in there to go ahead and bring in a lot of daylighting, that'll start to have an impact on the thermal performance because the glazing just tends to be not as thermally controllable as the kind of solid walled surfaces. So it's kind of that separation, but it's that balance between things. It's, because a lot of times we'll sacrifice thermal performance in one specific area. We'll have to make it up somewhere else, but we do want a good view, so if we did kind of sort of strictly one variable optimizations, we might all live in closed buildings with no windows in them or something like that, but that would be very boring and not very aesthetically desirable. So you can't just sort of treat it strictly as an engineering problem. And somewhere between our engineering needs and our aesthetic and social desires and all that, it all has to work together. There's no right solution to all this. So you're going to strike a balance on the climate side between heat and cold, and how you provide ventilation. Visually balancing sort of when you want views versus where you want privacy. Sometimes a little bit on lighting. A lot of times we like daylighting in, but sometimes you have to put shading in to go ahead and prevent excessive daylighting. So in some places where it's just getting very hot sun in the middle of the day, that may be unusable. Unless you put some shading in to sort of balance and sort of compensate for them. But a good layered strategy will really, do a good job of sort of accommodating both needs. And that's really what I'd like to stress is that really, it's a lot of it's all about developing what we call layered strategies. It's not just sort of a single approach that's going to blast through. You have to think about kind of what would be good in a summertime condition, what would be good in a spring or a winter condition, and then kind of find ways of layering them together. Okay, where maybe a little bit of both, or different features kick in at different times to sort of bring in the features that you might like at that time. Let me go ahead and what I want to do is actually, I found a really cool video that came out of a TED Talk. TED Talks are actually fantastic places for doing a lot of things. There was one all about architecture and kind of recent approaches to architecture. And let me go ahead and play a little bit of it for you. It's by an architect named Ole Scheer. And let's see if I can actually make this make sense. Let me come back over here. If I come back and I say wall plate 1, I have to get the sound. See if this will actually work. Okay, let me try this. So it starts, the whole talk is actually quite interesting, but right around 7.5, right about in there. See if I can make this work. He's talking, you're not hearing. Let me try it over here. Wall plate 1. Let's see if I got it over here. Here, wall plate 1. Let me try one other thing in terms of the sound. Make sure the sound is going where I think it's going. Should be going there. Okay, try again. It's not. It's not muted. So, if I can't do that, I'm going to take that out and just play it on my little speakers. Well, actually, let's try that. Nothing coming? Okay.
But of course, there's another story to this building. It is the story of the people that made it. 400 engineers and architects that I was guiding over all
That's the other building. Okay, now we
in
are.
China. This is a residential development in Singapore, large scale. If we look at Singapore, like most of Asia and more of the world, of course, it is dominated by the tower, a typology that indeed creates more isolation than connectedness. And I wanted to ask, how could we think about living not only in terms of the privacy and individuality of ourselves and our apartment, but in an idea of a collective? How could we think about creating a communal environment in which sharing things was as great as having your own? The typical answer to the question, we had to design 1,040 apartments, would have looked like this: 24-story height limit given by the planning authorities, 12 towers with nothing but residual in between. A very tight system that, although the tower isolates you, it doesn't even give you privacy because you're so close to the next one that it is very questionable what the qualities of this would be. So I proposed to topple the towers, throw the vertical into the horizontal and stack them up. And what looks like a bit random from the side, if you look from the viewpoint of the helicopter, you can see its organizational structure is actually a hexagonal grid in which these horizontal building blocks are stacked up to create huge outdoor courtyards, central spaces for the community, programmed with a variety of amenities and functions. And you see that these courtyards are not hermetically sealed spaces. They're open, permeable, they're interconnected. We call the project the interlace, thinking that we interlace and interconnect the human beings and the spaces alike. And the detailed quality of everything we designed was about animating this space and giving this space to the inhabitants. And in fact, it was a system where we would layer primarily communal spaces stacked to more and more individual and private spaces. So we would open up a spectrum between the collective and the individual. A little piece of maths: if we count all the green that we left on the ground minus the footprint of the buildings, and we would add back the green of all the terraces, we have 112% green space, so more nature than not having built a building. And of course, this little piece of maths shows you that we are multiplying the space available to those who live there. This is in fact the 13th floor of one of these terraces, so you see new datum planes, new ground planes for social activity. We paid a lot of attention to sustainability. In the tropics, the sun is the most important thing to pay attention to, and in fact it is seeking protection from the sun. We first proved that all apartments would have sufficient daylight throughout the year. We then went on to optimize the glazing of the facades to minimize the energy consumption of the building. But most importantly, we could prove that through the geometry of the building design, the building itself would provide sufficient shading to the courtyards so that those would be usable throughout the entire year. We further placed water bodies along the prevailing wind corridors so that evaporative cooling would create microclimates that again would enhance the quality of those spaces available for the inhabitants. And it was the idea of creating this variety of choices, a freedom to think where you would want to be, where you would want to escape maybe, within the own complexity of the complex in which you live.
Okay, so let's go ahead and stop there. Yes, I provide this really as more inspiration of thinking about a whole methodology about how you might approach it. And I think he really talked about some really good overall principles about how we can approach this. This whole notion of, ultimately they were trying to organize around green spaces, have a real connection to the outdoors. Really, it's kind of quite interesting that you could, through green roofs and multiple terraces, actually have more green space than there was originally on the site. But that as they were thinking about this block of buildings, after they got the overall blocking down, he started with the whole notion of, okay, let's go ahead and first see if we can get daylighting into the interior spaces, make sure everyone gets adequate daylighting. Okay. After we figure out how we can get daylighting in, then he said, let's go ahead and optimize the facades. So really think about the facades and where we need to either change their thermal properties or change their face shading properties, providing the daylighting, but doing it in a way that's going to be thermally the most effective way of providing that. Super. After we got that, Then they check the whole notion of really how are we doing with the building actually as a shading element. In Singapore, where it's so sunny throughout the year, the idea of being able to provide some shade to make an outdoor space useful is very important. So as you think about the sun, not just at high noon, but as the sun swings through the sky, how the shapes of the buildings wrap the courtyards and ultimately provide a little bit of shelter, even though they're outdoor spaces. They're shaded by the building, or we could be providing shade structures. And then even the last one I thought was really quite good, that when you started talking about the placement of the bodies of water and really using that as really a passive cooling mechanism was quite nice. Because you can imagine in a building like this, if we do have an opportunity to have some ventilation blowing through, we could naturally start to cool the buildings. But even better than just a breeze blowing through, if a breeze is blowing across water, it'll actually feel a little bit cooler. Because it uses the water, as the water vaporizes, takes a little bit of heat to do that, takes a little bit of energy to do that, so it actually cools down the air, which is kind of a principle of like swamp cooling or kind of evaporative cooling. So, just a cool inspiration to think about how you can start combining a lot of different systems together. Yeah, Henry.
The square footage is the same in the initial concept.
Again?
Oh yeah. The square footage of the apartments.
He was basically saying that he could provide this, provide the same 1,000 apartments, same sort of square footage, but doing it in this sort of horizontally laid out city as opposed to all these vertical towers.
Did it occupy the same? But do you know if it occupied the same land space?
He had the same land space to work with. In the build them as vertical towers, it would be taking away from land space. So it's the same overall footprint, but then what's happening here is by sort of laying them this way and taking advantage of all those new horizontal surfaces as new land space, he actually got a net positive out of it. So quite an interesting building. Actually, have you been here? This new one? No? It seems like quite an interesting one. It's one I have to go visit. I think it's recently won some awards. It's actually quite an interesting approach. As you look at it, it's kind of in a very exciting sort of space. You might imagine if you're thinking about it from a structural perspective, there's a lot of interesting challenges going on here.
Where is it again?
This is in Singapore. And it's called like the interlace. Something like that.
And who's the architect on it?
What's his name? It is Ole Sheeran.
Do you know who did the environmental design analysis?
That I don't know. Be a good one to look up, right? Yeah, you want to sort of like find out really who is responsible for a lot of the overall environmental planning on it. Okay. Other examples, though, to kind of get you going. There's a couple of other examples that are even sort of floating around out there just as Revit models that you can start to take a look at. In the Canvas folder, I've always gone ahead and put a couple of different files out there for you of different Revit models that sort of illustrate some interesting principles. There's the Audubon Center, which is that little sort of bird watching kind of center. And that has a pretty well developed and interesting facade. There's also a whole hospital project. That's quite an interesting one. That also has kind of an interesting facade designed with some sustainability considerations. And if you just go on out there and take a look at some of those, let me go to, where did I put the Audubon Center? Over here. Let's open that guy up. Okay, as it opens here, we'll take a look at the exterior of the building. I should always change that. Open this every time. It's kind of an interesting building. Even from this facade, you can start to see different things happening in different facades. This is currently, you can kind of think about it. I believe this is the eastern facade. What's going on here, you see that a lot of the building, this is a lot of mechanical space, more utility space back over here, has relatively high walls. There's really not a lot of direct sunlight coming in these rooms. A few windows, what I'll call punched windows. Up near the top, though, There's an attempt to go through and get some lighting into the building, into a central hallway. And that's being done not through the windows right here. There's one space that has some windows in the doorway. But there's a whole series of clear story windows, which is over a hallway, which is kind of running centrally through the building. So there's a lot of ways to get lighting into the center. This kind of space over here, which has an awful lot of glass. Anyone want to venture a guess about what that space is? You think that's private offices? Is that a very public space? What would you guess something like that is?
It's pretty public.
Is that? It's definitely more public. This is actually like the cafeteria space. Something like that, a very common space. There's probably some very nice views out here. As you look at the full facade of the building, this is kind of an interesting space too. I'm not sure what that is right offhand, but again, it's pretty public. It sort of pokes out. There's like glass on three sides of it. So that's pretty interesting. Up here on the top of the building, you'll see right in the center, there's some little oculus right there. So there's some daylighting coming down, and that's probably central lobby, and there's some sort of a skylight feature right there. As we orbit around to the other side, you'll see it's pretty boring and utilitarian on this end. We have some slightly different considerations. Oh, actually, that's the north side. That's interesting. So it's getting a lot of north side, and I'm just sort of finally seeing the compass up at the top. Here we are on the southern side of the building. So let's take a look at the southern side of the building, what's different over there. So we have a lot of glass on the southern side. These are some classrooms and some spaces that are public spaces. But because it's on the south side, we don't necessarily want all the sun kind of baking in during the summertime. So you start seeing these large roof overhangs. Okay? You also have these light shelves a little bit further down the wall, right over the door height and stuff like that. So that's kind of a common strategy for thinking about southern sides. Even over here at the main walk, we have sort of a large overhang that's covering kind of the doors that are coming out towards the walk. So on the south side, we're seeing something interesting. Over here on the side of these classroom buildings, see, it's not just all curtain walls. We have some variation here. They have some little punched windows, which are creating a little architectural feature there. If I go around to the western side, let's take a look at what's happening here. The western side, again, is typically where you get the sun in the late afternoon. So we have some kind of glass towards the western side, but largely kind of a large sheer face there. Yeah, face there. Part of what's going on here is you've got to sort of always balance where the views are, where the light is, and just really try to work together. But I show you this building just to sort of say that, or to kind of inspire you to think that like buildings don't have to be one-dimensional. It doesn't have to be a big sheer wall and all the windows look exactly the same. You can start varying things and kind of actually have very interesting patterns. Okay, another one I wanted to share with you. Close that up, is the hospital project. The hospital project is actually a very good one too. We'll talk about that a little bit later when we talk about more systems integration, how structure and mechanical and all that get together. Let me open that up. The hospital project also was designed with a real sustainability bent in mind. So if you open that up, take a look at what's happening inside there. Okay, let's let it finish grinding its way up. Working. Okay, finally opening everything. This is actually a rather large project. It's pretty complex. So let's take a look at this one ever so briefly. This one, if you take a look at it, was also designed kind of from a sustainability standpoint. The south is down towards, the lower left-hand corner of our screen right now. You see the building actually sort of follows a curve. It's basically designed so that these faces of the buildings follow the sun. So as the sun moves around in the sky, there's always some face that's trying to maximize that. You'll see up on the roof there's a lot of solar panels. In this case, they're using most of the area as solar panels for collection, but they've also included some green terraces kind of between the buildings over here on the west and on the east sides. So even if you're in one of these hospital rooms that's up on the 3rd or 4th floor, you're not looking down in a parking lot. Hopefully you're looking out at a garden, or you and your visitors who are coming to see you can go out into the garden and enjoy a bit of quiet time away from the very institutional hospital setting. So it's a nice thing about bringing the green up into the environment and kind of creating some nice spaces there. As you look at the facades are actually articulated in kind of an interesting way. If I spin that around a little bit more, you see the little helicopter on the top, or the heliport on the top. But if you look at the facade, you'll see it's a variety of different materials going on right now. There are, sort of down at the lower 2 floors, a fairly common construction. We have like stone and maybe some brick above with some punched windows happening down here. But when we get up to the patient floors, you see more of this banding of stone material with, just like glass that's moving along like ribbons of glass, so it feels very continuous for you there. It's a very different message. This part up here in the front of the building, which is actually the southernmost point in the building, actually has a big sloping glass surface. Okay. That sloping glass surface, you'll notice, actually has a little bit of tilt to it. It has a little bit of self-shading going on for it. But really what's going on there, I'd say that's not so much about sort of the energy performance, although the shading helps out a little. That's actually a big lobby space, a big multi-story lobby space, and they wanted a very big, dramatic, kind of welcoming entry. So they created something like that. Okay. Even down here at the entry, notice there's so many things you can do to sort of create a sense of entry for your building. Here, okay, the entry is down at the bottom. You'll see they've created just a little bit of a canopy for the entry. So right down here at the bottom, the doors are there, but they're all shaded so that as you walk through the doors, the rain is staying off your head. You're not immediately walking out into the bright sunlight. You have a little bit of a transition zone. But that can still be sort of very dramatic. You see it's this big cantilevered kind of canopy coming across there, just providing a little bit of architectural interest. So I want to just really share these examples with you to kind of demonstrate the point that, a good building envelope really sort of has a combination of sort of architectural interest, kind of welcoming features, variation in different materials, variations in different amounts of kind of privacy versus being able to see through. It's a combination of different things. So don't think that like if you come up with one message, it has to be the same message at all 4 sides of your building. A well-designed facade actually has a little bit of kind of different elements on all sides. Okay, enough of all that. Any questions about that to get going? You good? Okay, then let us go ahead and we are going to shift our focus a little bit. Back to the whole issue of, okay, what do we do in Revit or with Revit and the tools we have available to go ahead and kind of play out and explore these strategies. So, where we left off last time was there were a couple of analysis tools that were available to us. Some of them all came as part of a single package that included daylighting analysis. It turns out it also includes lighting analysis for electrical lights, as well as kind of solar radiation analysis. So a lot of analysis tools are all tied together into a single sort of extension. Again, that's like a lighting for Revit. You can find it either on the Autodesk side, or I loaded a copy for you out into Canvas. So you go to the software installs folder. Let's see what we have there. It's Autodesk Lighting Analysis. And if you pull that on down and install it into your machine, you'll pick up several different tools under the Analyze tab. And we're going to play around with those tools today. We'll do a little bit of daylighting, but we'll also talk about a little bit of, electrical lighting, in honor of my friends in the second row who are experimenting with this relative to the 256 class, which is sort of trying to use, see if we can use Revit to do things like that in that class too. But let's go ahead and start out by just creating a very simple building for ourselves that'll really just give us the ability to sort of play with that. So what I'm going to do is just play around with daylighting, and as we're kind of doing some analysis, we'll think about what our goals are. But I'll give ourselves a little time. I'm going to just do a new little architectural template. I'll create the same little L-shaped building that I always create, or a very similar one. The big restrictions are it basically has to have a building, has to have a floor to it, and it must have rooms to it to do daylighting. Okay. Hopefully it has a roof or some sort of cover at the top. Otherwise, your daylighting is going to be very, very strong. So I'll say let's go to create some walls architectural. And what do we do here? Let's choose some sort of wall type. Let's see what I got available to me. It's working too hard. I think it's because the hospital's still open in the background. It's thinking too hard. If your machine is done thinking, just go ahead and start sketching just some shape building. Revit's fighting with me. What are you doing? Ah, there's actually a dialogue open in the background somewhere. Coming back. Oh, there we go. I have a lot of things open there right now. Do this. I'm just going to close Revit and kind of bring it back up again, because no reason for you to suffer through the poor performance. Okay, so again, I'm going to create a little L-shaped building. We're going to put some walls on it, put a little bit of maybe some curtain wall, and a few windows in it, and just kind of check out just really what the daylighting is as it gets in there. We're going to show you how we, again, sort of create like colorful maps that illustrate how the daylighting is penetrating the building, but we're also going to show you how you get true values, a data grid of values out, which is something we never played around with before. But thanks to my friends in the second row, we got an answer about how to do this. So let's go ahead and open this up. Finish spinning over there. Yes, communicator. They're lovely, but I don't want you right now. Okay, say new architectural template. Okay, back to where we were. I'm going to go over to walls. Say that I'm going to go up to the second level because I don't want to go all the way up unconnected. I'll choose some nice type. Again, eventually I'm going to start worrying about this thermally, but I'll just choose the brick and CMU, or the brick on metal stud for now. Make my little L-shaped building. Come on over here. Okay, once I've created the basic shape, again, the things I need to start thinking about doing are, it always needs to have a floor, so I'll put an architectural floor on it. For this floor, well, what do I want to do? I'll just leave it generic for right now. It's going to feel like creating a slab floor for it right now. I'll say let's go through and make it cover all those sides. Okay. The floor is a requirement just of the lighting analysis tool. It thinks about rooms and thinks about floors, so it tries to measure a height above the floor for reporting some values. That's why it needs a floor. Okay, I'm also going to put a little roof on this, roof by footprint. I'll put it at level 2, maybe a little 1 foot overhang. Again, that's not a very sensible one, but it'll get us going for now. got all the different sides. I'm going to turn off the slopes. Okay, so now I have something which should look pretty much like On God's building. A pretty basic little building right there. At this point, we want to do two things that are going to help us out analytically. For the daylighting purposes, we want to put a room in there. So go to the room tool. The room tool, again, has this notion of how high it's going to go looking for the ceiling. I'm going to make it higher than what I know the ceiling is, just so it'll go up and catch the roof. If it's less than that, it'll think it's unbounded at the top. If it doesn't hit a ceiling or it doesn't hit a floor above, it'll think there's a big unbounded surface. It won't know how to analyze it, so making it taller just lets it find the ceiling or find the roof so that it knows it has a top. Okay. Similarly, we're going to go through and put in something called a space. A space in some ways is very much like a room. A space just starts to have the notion of occupancy, which then lets us compute a power density, compute a certain load that the people in it are going to generate in terms of how much heating and cooling they'll need to kind of keep them comfortable. So a space is another sort of really valuable concept. It also has that notion of the offset. So let's put a space in there. It'll be sort of transparent to us, but now we have a space and we have a room. Okay, and if we choose the space, we can kind of adjust its properties, but I'll leave it alone for now. Okay, last thing I want to do relative to lighting, though, is get us started, is put a little window in here somewhere. So have some fun with this. Whatever you would like, I'm going to go through and put in a few windows on the backside. Kind of a very standard kind of punch strategy. And I'll put some over here too. Okay, maybe one over there. Okay, so those are some standard windows. I'm also going to put a little curtain wall in because we love to put curtain walls in, but we have to sort of think about what the impact of curtain walls is because it's a big, bold move with big, bold implications. So to do that, I'm going to go to the modify, choose modify, and I'm going to do a little splitting. I've learned to just sort of split things off and make curtain walls that way. So I'll take that little wall and that little wall right there, and I'll change it to storefront. Okay, now I haven't been thinking about the thermal properties very much. We'll think about that in a little bit. But here's my basic building. So what do you think? As you look at this building and you're thinking about the LEED daylighting requirements, which really come down to this whole notion of, is there sort of a minimally acceptable level of light kind of in the core of the building? And like, I think it's 80%, something like that. Okay, I promise I'll look it up. It's a certain level of kind of like minimally acceptable lights in the core of the building. You can sort of guess right now whether you think you have enough light or too much light or too little light in the center of that building. And in terms of the way the requirements are written for daylighting, it's possible to not only be too low on the light level, you could actually be too high on the light level. Okay, so if you're sitting in front of a big bank of windows, you might hit that consideration. Okay, to analyze this building, let us go ahead and do this. We'll go to the Analyze tab, and hopefully you have something called lighting showing up in there. Again, if you don't, we just need to load that tool into your system. Okay? You'll need to be signed in with your Autodesk ID, just so you can get access to the analysis tools. And we'll say we're going to do a new lighting analysis. Have to save my document first. Okay. Let me do a little save. Okay, daylighting. Super. So this is all a side lighting strategy. If I was thinking about it, I'm bringing all the light from the side, none from the top. We could put in some skylights, and that would change that. Some things it wants us to do. It wants us to put in a location. If we don't put in a location, it'll assume Boston. Boston's always kind of its default. Okay. We need to have surface and glazing materials. Check. We need to have rooms. Check. Okay, we're in pretty good shape. as we open up this dialog, there's a couple of different choices about the types of analysis it'll do. By default, this was designed to do like lead daylighting analysis, but you're going to find out it can do some other sorts of analysis too. So for lead daylighting analysis, let's go ahead and use the new standard, which is LEED version 4. Okay, so what is this? Environmental quality, C7 option 2. This is where basically we're looking for a level of illuminance, okay, between 300 to 3,000 lux. Okay, so less than that, too dark. Greater than that, considered to be too warm, but that's considered to be a comfortable level of lighting. We can choose which different levels we want to go to, whether it's a single level or all levels. Since we only have a single level, that's all it'll analyze. Let me kind of check this. There's this choice that if you click the little gear, brings up some custom settings. By default, override lighting scheme is turned on. If you leave override lighting scheme turned on, it will go through and use the lead evaluation. We're going to find out in a little while why, if we turn that off, we can get it to consider artificial lights in addition to the lead natural daylighting. Okay. But for now, let's leave it overriding it. I was doing some experimentation. Yours probably is still set to override it. Okay, so basically we are ready to do some calculations. You can do high resolution or low resolution. For our purposes, it's really just a question of like how many grid points it's going to use and how accurate it's going to compute it. Yeah, as a starting point, low will just speed things up a little bit, although it's all going to the cloud, so you may not see the difference. We will say, hey, let's check the price. Hopefully because you're a student, it says 0 credits in there. If it doesn't say 0 credits in there, you may need another student ID, or we need another ID to log in, but it should say 0 in there. And you will say start the analysis. And what's it going to do? It's going to send this thing off. It's going to go off to the cloud. And based upon the sun being in 2 different positions, is it like 9 in the morning and 3 in the morning on September 21st, it's going to go through and compute just how much daylighting is in the core of that building and give us a color map to show how that is. So that's how LEED does it. But as it's doing that for just a second, let's go ahead and stop and consider about what it's doing and what we're trying to achieve here. Because there really are some different guidelines about what good daylighting is, and let me share some with you. If you, for example, go over to Canvas and go into session 7, you will find something called lighting level recommendations. It's a big PDF document. And you'll see what it does is it prescribes different lighting levels to different categories. So we'll group things into low lighting level spaces like public spaces with dark surroundings or simple orientation lighting for short temporary visits, all the way down to very high contrast lighting where we really want a very bright, intense light because we're really trying to do some very precision work where it's important that we see things. Okay, so if you're hanging out in the main lobby or out by Coupa, you're probably kind of down in the B zone, something like that. Workspaces where visual tasks are only occasionally performed, so maybe some meeting rooms or rooms where you're not doing very high accuracy work is more in the C zone. Visual tasks with high contrast or high size, medium contrast, low contrast, or very small size. Oh, this gets into, if you're working on a very fine thing with a jeweler's screwdriver and replacing parts of a computer, okay, you're looking at something that's a very small size or possibly a low contrast. Things that are big, you can see pretty well even in a dim setting. So high contrast, very black versus white, very big, easy to miss. But you'll see that there's a range anywhere from 20 to 50 all the way up to 100 to 200. Now, what these different ranges are, there's sort of a minimum, kind of average, sort of maximum in there. And it actually varies not only in terms of what you're trying to achieve, it sort of depends on your user base. So if you're designing a space for little kids who actually have pretty good eyesight, okay, they can actually typically get by with lower levels of light. When people get older and your eyes get a little fuzzier and have a little bit harder time reading things, okay, you actually typically need a little bit more light to read things. That's sort of what I end up doing now. If I have very small print on something, you'll find me going up under a light and just trying to get greater contrast so I can sort of read those teeny tiny letters. Okay, but there's a range in here, and for most of our work, anywhere from 50 to 200 is kind of a pretty good level of foot candles. Anywhere from 500 to 2,000 is a pretty good range of lux. In general, these are just two different systems, a British system versus kind of a metric system. And in general, lux is around 10 foot candles. They just sort of scale. So as you're looking at different values, you just have to be aware of which scale you're in. Realize for the LEED criteria, we're going anywhere from 300 all the way up to 3,000. Okay, yeah. Anything above that, okay, is really going to be too bright. So if you can picture, like in the old detective dramas, they sit you down, they put the bright light in your face, and they make you sweat. You know, that's when it's just uncomfortable. In the same way that if I just set you down in front of the windows on the south side in the direct sun of this building, you'd probably get uncomfortable after a few minutes too. It's not a great place to be working, which is why we typically put shades in. Okay, so we're shooting for these kind of general levels. If you keep going down, you can, for all sorts of different kind of specific activities, just see what sort of levels of lighting are recommended. So if you're doing graphic design, where you're selecting colors or charting or mapping, it's a pretty high level. Okay? Drafting is pretty high level. Auditorium for social activity, fairly low level, more like B-level lighting. Patient rooms for observation, A, very dim in there. So, just different levels of lighting for all sorts of different functions. Interestingly, museums, it's an autopsy and morgue museum. I don't want to look at that. They tend to be fairly bright. See if I can find more of a museum. That's all medical. That's healthcare. Oh, I need to just find some educational things. Lecture rooms tend to be fairly bright. Science labs, not so much. Interesting. But there's all these different recommendations about offices. Offices, the lobbies are sort of C level. Mail sorting, which requires a little more work, or brighter lights, is an E level. So just different lighting levels to sort of shoot for. Okay, those lighting levels and LEED are actually sort of independent of each other, though, because LEED's sort of computed regardless of what those levels are. But let's start with that. Does that sort of make sense in terms of bright light versus not so bright light? Okay, if that's sort of making sense to you, let's come back over and see how we're doing here. Okay. I've gone through, I've computed some sort of lighting here. I'm not seeing any lighting just yet, but let's go ahead and see if we can kind of come up with the values. What I'll do is come over to lighting and choose lighting, see if it's done computing. Still says I'm pending right now. Is anyone not pending? Did anyone make it through yet, or are we all sort of pending still? Because the problem when you're working out on the cloud is you're sort of waiting for the cloud to kind of put you in the queue. Does anyone have anything yet, or not quite yet? Not quite yet?
Didn't download the lighting thing, I'm just watching.
No worries. Okay, we're going to let it continue to run right there. Let's, as we're talking about lighting, stop to consider as we're waiting on this how we can start thinking about introducing daylighting in different ways. Because what you'll learn as you start thinking about doing daylighting, there's sort of two primary strategies for getting daylighting in. You tend to either think about getting daylighting in through the sides, or you get daylighting in from the top, okay? And depending on the configuration of your building, if you have a multi-story building, okay, it's often necessary to go through the sides because you can't always get to the center unless you have something like an atrium or something which is a light well to bring light down into the center of the space that could actually penetrate multiple floors. But there's a lot of ways you can do it. And I put together really a whole series of different Revit models to illustrate some of those. And we can take a look at them as we're waiting for this thing to compute. So if you go on out to session 7 and open up daylighting sample buildings, let me even kind of unzip that. You'll see there's a whole lot of buildings that are set up in Revit. Oops, not that. can stop that over there. You, no, don't. Okay. Okay, let's come back over here. So in the daylighting sample buildings, you will find everything from a base case, which has no windows, to several different window strategies. My base case, I always do these little base cases, which are sort of, kind of very similar. It's just a little building that has, a little square building, has 4 basically offices and a hallway, but no lighting in it. Too much flashing around. Okay, here's my little base building. It's pretty boring in terms of what's going on here. As I think about this, rather than opening them all up, maybe I'll start drawing some of them in here. I'll change it to consistent colors. The idea is I can go through and put in kind of what I'll call vision windows. If I want to put in vision windows, what I'm going to do is basically just place them kind of on the side here. Kind of badly drawn. Maybe it's almost easier to do it this way. I'll say window. Okay. These would typically be considered vision windows. That's fine. All right. Okay. The idea with vision windows is you're putting them at such a height that basically not only are they providing light in, but people can see out of them. So these are sort of what I call vision windows. Okay. Vision windows are generally pretty good for getting light in there, but they have the problem in that they also sort of have a view. So if you have a classroom in there and you don't want people to be distracted, or you just don't want people to be able to see into the room, that may not be very good. So in addition to vision windows, sometimes we go through and put in what we'll call clear story windows, or just lighting windows. And lighting windows are somewhat similar. Let's put them up in here. They tend to be, oops, wrong way. I'm more interested in a window like this, which is up here. Okay. This is a window where if you see windows like this up high above the other windows, okay, what you're doing in there is that's strictly for the purpose of bringing daylighting in. I guess you could be looking up at the sky too, but it's really all about just bringing daylighting in above people's heads and stuff like that. A very useful strategy for places where you don't necessarily want a view, for example, in bathrooms or something like that. If you have bathrooms on the exterior wall and you don't want a view, okay, you then go ahead and put the lights in very tall. That's also used a lot in classrooms and stuff like that. If I have a classroom in here, I want the lighting, but I don't want people looking out the windows during the middle of class. Okay, you sort of could put windows in up there. Okay, so that's kind of a very common strategy. Other strategies, there's a lot of things we can do in terms of all these. We can take these windows and we can start bringing them together, kind of pairing them up in different ways. Right now I'm looking at them as individual windows, but it's quite common to think about sort of pulling these together to form some sort of nice geometric pattern. In fact, if you look at the outside of the Y2E2 building, you'll see we have windows that are pretty similar to this, but if you notice on the outside of Y2E2, they're actually sort of gathered together in different ways. Looks like my analysis is done. So even on the exterior of Y2E2, put them all in there, looking kind of a little bit clunky right now. We come back over here. See if I can come out. Let's say Y2E2 exterior images. The cool thing about Y2E2 is it's a known term now. Okay, what can you see happening in our windows here? See, our windows aren't strictly individual windows. What they tend to be is either little pairs of windows that are joined together or four windows that are joined together. And we often kind of clump these little windows together to create little architectural patterns. Because at a high level, you like just a little bit of order to the whole thing. You like a little systematic order to it. Notice in our facade, though, we actually have a combination of what I'll call punch windows. And then in some key places, we actually have this curtain wall panel going down. That curtain wall panel, typically being a place there's a lot more or less privacy, a lot more public space, it's often a cue for you that, hey, something public and very open to you is happening there. These are, there's a conference room above and a doorway going out to the second floor terrace. There's actually offices behind that one, so it's actually sort of violating the rule a little bit. But usually when you see large expanses of glass like that, it's being muted from you. In fact, in our building, if you're wandering up and down the halls are in two hallways of our building versus all the closed door offices. Who has glass panel offices?
Admin.
Admins do.